రావట్లేదు, ఫోటో రావాలి కదా.
మనకు కనిపించదు సార్ ఫోటో. వీడియో కంప్లీట్ అయిపోయి కాలం మనకు కనిపిస్తుంది.
అయితే ఇప్పుడు డిలీట్ చేశాను నేను. ఇప్పుడు ఇందాక నేను చెప్పేటప్పుడు ఉంది కదా, ఇందాక చెప్పేటప్పుడు ఉంది కదా మేడం.
అది మనం పీపీటీ ఆన్ చేయకముందే ఉంటుంది సార్. వన్స్ ఆన్ చేస్తే అది ఆటోమేటిక్గా పోతుంది. చూడండి నెక్స్ట్.
అవి డిలీట్ చేశాను మేడం.
అది
3, 2, 1
మీరు కనిపిస్తారు, మీరేం వరీ అవసరం లేదు, అది ఆటోమేటిక్గా
అంటే కనిపించట్లేదని.
లేదు సార్, పీపీటీ ఆన్ చేస్తే మనం కనిపించాము కానీ వీడియోలో కనిపిస్తాం.
ఇప్పుడు ఆన్ చేసి ఉన్నట్టు కదా మనం.
లేదు సార్, నేను తీసేస్తాను. స్టార్ట్ చేసాను సార్.
స్టార్ట్ చేసాను. Good afternoon to all of you. Today's topic is fiber reinforced concrete. It is very important. That is avoids the cracks and strength is more than conventional concrete. And that contents are introduction and what is fiber reinforced concrete, history of fiber concrete. Reinforced types of mixed proportion of FRC, mechanical properties of FRC, where FRC is a fiber reinforced concrete, the application of FRC, factor affecting the properties of FRC, advantages and disadvantages, and effects of fiber reinforced concrete. First one, introduction of fiber concrete. It is contains fibrous material. Concrete is containing fibrous material which is increased its structurally integrity. That is conventional concrete with fibers. That is fiber reinforced concrete. It contains short discrete fibers that are uniformly distributed and randomly oriented. I will tell you later that orientation, it is a fact affecting the fiber reinforced concrete. How we are orientation, the fibers are in concrete. I will tell you later. That last one, the introduction. Fiber includes steel fibers, glass fibers, and synthetic fibers, natural fibers, acquire varying properties to the concrete. Second topic is what is fiber reinforced concrete. It is which is gaining increasing importance, and adding of fiber reinforced is discrete, means it is separate, individually separate form, improve many engineering properties of concrete. That is fiber. History of reinforced concrete is as is applicable for other fields. That is fiber. Suppose in wooden work table we are preparing with wood. Fiber reinforced material when you are using instead of wood, it's a very strength than wood. That is also, it is a history. Earlier it is 30-40 years back, that is fiber reinforced concrete we used. In the early years, straw and mortar were used for producing mud bricks, and horsehair was also we are using. That is also a fiber. As the fiber technology developed, cement was reinforced by asbestos fibers. This asbestos sheets also, that is 30-40 years back we that is used. That is with asbestos is a fiber in the early 20th century. Fiber reinforced concrete used is industrial flooring and sprayed concrete. And sprayed concrete means it is sprayed to the area by pumping. That is also including fibers. That concrete is slender structure is usually it is a precast plants we are using. fire resistant structures. This is also is a we are FRC we are using. Mortar application is a rehabilitation. Types of fiber reinforcement is steel fibers reinforced concrete. It is basically cheaper and easier to use form of rebar reinforcement. That rebar, when the bar is removing and rebar within the liquid cement, which requires a greater deal of preparation of work, but make for a much stronger concrete. That is like that glass fiber also. It is a fiber including concrete. It is much like you would find the fiberglass insulation to reinforce the concrete. Synthetic fiber also, that is nylon fibers to improve the concrete strength, and it's in a number of benefits over the other. The mixed proportion is as per syllabus. It is a mixed proportion is very important. Already we learned in graduation that is a mixed proportion. In that we are adding fibers. That is cement is OPC, ordinary Portland cement, 53 grade. Fine aggregate is river sand and zone 2 as per area. Coarse aggregate. Size 10 mm usually when we are using fiberglass. The size when it is increased, the mortar is reduced. When we are reducing the mortar, the strength will be decreases. That's why we are using 10 mm size of aggregate. Specific gravity of that is 2.79 and water absorption 1.19 percentage. That absorption of water generally 0.06 to 0.8, but here we are water absorption capacity is 1.19% to be there. Admixtures Secament NN is a superplasticizer and type superplasticizer is admixtures, and steel fibers diameter is 0.6 and length is 50 mm and aspect ratio L by D is 83.33. 50 by 0.66 will get to 83.33 is L by D ratio. L by D ratio is aspect ratio, that is in, I will explain in the factors affecting fiber reinforced concrete. Here tensile strength is 1100 Newton per mm square MPa, and mixed proportion 50 kg of cement, 32.5 liters per water, coarse aggregate, fine aggregate. These are all as per conventional concrete. PPF and SF, steel fibers and plastic fibers, these are also we are using that mixed proportion. And mixing and method, casting methods. Fibers are added to cement first, mixed and kept aside. After that, fiber added to concrete usually 0.1 to 3% by weight of cement. And the optimum dosage of depends on the type of fiber and its practical application. Now introduce a coarse aggregate, fine aggregate, fiber mixed cement. It is into mixture, that is as usual is a conventional concrete. Mix them thoroughly, those fibers and conventional concrete, and add water and again mix the mixture for the minute. Pour out the mixture, then concrete is ready to use. Then when you are using this is avoid the cracks and will give more strength. The casting is same as a conventional concrete. Already I told this is a as usually it is a conventional concrete and we are adding fibers extra. Application of fiber reinforced concrete. It is used runways and airfield, that is road pavements, industrial footings. Industrial footings means why you are that chemical, when we are having the soil having chemicals, at that time we require when you are pouring the concrete for footing, then you have to add fibers. Then only it will not squeeze the chemical, then will give more strength. That's why these applications are very important, that fiber reinforced concrete. Not only runways and road pavements, we are using in industrial. Yeah, and another one used for fabrication of precast products like pipes, boards, beams, staircase, steps, wall panels. These are all precast fiber elements we are using nowadays. That's why I told first that fiber reinforced concrete is very important, and applications are also so many places we are using. It is also being tried for the manufacturing of prefabricated formwork, modulus of U shape, for casting lintels and small beams, like pipes, boards, beams, how we are preparing like that U shape. And simultaneously in stadiums, for cricket stadiums, curved dooms also we required. By this application, fiber reinforced concrete at middle floors we are using. When the top floors is concrete curved, and the middle floors we are using this fiber reinforced concrete roofs. And finally, dams and hydraulic structures. That is, FRC is being used for the construction and repairs of the dam and hydraulic structures also. These applications of FRC. And the factors affecting properties, it is very important. There are four topics in that. There are four factors: volume of fibers, aspect ratio of fibers, orientation of fibers, and relative fiber matrix stiffness. First one is volume of fiber. Low volume factor, it is less than 1% used in slabs and pavements. That is low volume factor. It is a medium, is a shotcrete. That is 1% to 2% is used. It is more than 2% used in high performance concrete. High performance is more than 40 M40. More than M40, then we will give this such type of more than 2% of volume of fiber will give high performance concrete. That is, we are using pre-stressed concrete and high performance concrete structures where we require, that is raft foundation and retaining wall structures where we require. Then at that place we required more than 2%. Second factor is aspect ratio is very important. That is L by D is the aspect. It is defined as a ratio length of fiber to its diameter. L by D is the aspect ratio. The typical aspect range aspect ratio is 30 to 150, not less than 30, not more than 150. Actually, we are using 30 to 150. It is a best aspect ratio. The aspect ratio up to 75 is increased strength and stiffness. Beyond 75, there is decreases in toughness. Up to 75 increased strength, beyond 75 is decreases in toughness. That is a second factor. And third factor is orientation of fibers. Orientation of fibers is parallelly and perpendicular and irregular, randomly we are using. That is fiber oriented parallel to applied load offers more strength and toughness than randomly distributed fibers. That is a orientation. And last factor is a relative fiber matrix. Low modulus of fibers imparts more energy absorption, and low modulus imparts strength and stiffness. And mechanical properties of FRC. This is a compressive strength that is 0 to 15%. The presence of fiber may after the failure mode of cylinders, but the fiber effect will be minor on the improvement of the compressive strength values, that is 0 to 15%. The modulus of velocity is of FRC increases slightly with an increase in the fiber's content. It was found that for each 1% increase in the fiber content by volume, there is an increase of 3% in the modulus of velocity. Actually, the compressive strength is 0 to 15%. Here it is content. It was found that for each 1% increases in the fiber content by volume, there is an increase is 3% of modulus of velocity. That is for modulus of velocity. Then flexure. The mechanical properties, flexure is one factor. That is flexure is nothing but it is a 2-point load and one single point load. Single point load rupture will give more strength than 2-point load. That is the flexure. The flexure strength was reported to be increased by 2.5 times using 4% fibers. Splitting tensile strength, the presence of 3% fiber by volume was reported to increase the splitting tensile strength of mortar about 2.5%, that of the unreinforced one. Actually, in graduation, cubic and cylinders we did, that is 0.637 strength. Here it is splitting tensile strength. When you are adding either in cubes or cylindrical, the split tensile strength is 2.5% that of the unreinforced one. Toughness. For FRC, toughness is about 10 to 40 times that of plain concrete. Fatigue strength is it is break even when it is the fatigue strength of about 90%. When you are adding addition of fibers in the concrete, the fatigue strength is about 90%. Impact resistance, the impact strength for fiber concrete is generally 5 to 10 times that of plain concrete, depending on the volume of the fiber. Advantage of fibers: high modulus of velocity for effective long-term reinforced even in the hardened concrete. Does not rust nor corrode and requires no minimum cover. It is when we are having a fiber that no minimum cover. It is not necessary. Conventional concrete for slab minimum it is 15 mm. For beam it's 25 mm. For columns 40 mm we are using. Here when you are adding fiber concrete, then it is we have to requires no minimum cover. Ideal aspect ratio, which makes already the aspect ratio range is 30 to 150. It is up to 75 is increased. Beyond that it is decreased. And high flexural strength depends on the additional rate. That is advantage. Can be made into thin sheets or irregular shapes. This is also advantage of FRC. Disadvantage is a greater reduction of workability and high cost of materials. Here it is a fiber reinforced concrete. One structure is there. It is when you are having a low bearing capacity of soil, and then we lay the slab, that is flooring with fibers, because safe bearing capacity of soil is very low. Then you have to lay PCC and flooring, whatever that cost. Then you have to lay the slab. It is a very strength, and there is no sinkage. That's why we are providing as per figure this fiberglass, including concrete for the flooring. That is historic fiber reinforcement. I have used natural fibers such as hay. Hay is the dry grass or air. While these fibers help the concrete strength, they can also make it weaker. Means already I told the safe bearing capacity of soil is very weak. Then this is at that time we have to use too much fiber will give more strength. Effect of fiber reinforced concrete is improved durability of the structure. Actually, conventional concrete is will give good strength, but improve the durability of the structure when you are using fiber reinforced concrete. Increase tensile and flexural strength also. In conventional concrete is averagely, but when you are using fiber reinforced concrete, it increase the tensile and simultaneously flexural strength. And the third point is higher resistance to later cracking. Actually, avoid the cracks purpose we are using, and sinkage also, and that is when you are using fibers in concrete, you will give higher resistance to later cracking. Even cracks visible also, it will not leakage. It is a bond, internal bonding is very much in that fiber reinforced concrete. That's why it is higher resistance. And fourth point is improved crack distribution. Crack, when we are having cracks in concrete, then we avoid the fibers and improve the distance of crack. It is lightly, because that fiber glass is depends upon aspect ratio. That is, cracks are reducing. And the next point is reduces sinkage of early age concrete. And another point, increase the fiber resistance of concrete, negative influence on workability, improved homogeneity of fresh concrete. These are all the effect of fiber reinforced concrete. And finally, it is a conclusion. The efficient utilization of fibrous concrete will give more strength and dynamic properties like tensile strength and energy absorption characteristics, and impact strength and fatigue strength. Already I told it is a 90% fatigue strength break-in point. It is more than conventional concrete. That's why we are using fiber reinforced concrete. The last point also provides a isotropic strength property not common in the conventional concrete. It is the same material. That isotropic means that same material strength, that is uniformly. That fiber, when you are adding conventional concrete, is a fiber reinforced concrete, and the isotropic strength property is not common in the conventional concrete. It is uniformly will give the more strength than the conventional concrete. Thank you. It is fifth unit is completed.